Hi guys, what's going on and welcome to another Azure Mythology tutorial. Today it's going to be about random map scripting. However, as you can see, we're not in IOM right now. We're in Visual Studio, and that is because there is no built-in tools to make your own random map in IOM. That's right, you have to go through the coding to make your own random map. However, fear not, as I will be providing a step-by-step tutorial on IOM random map scripting. The IOM random map scripting language is a language based on C. So we have to teach you how to use the C language and the general syntax of the C language. I will be using Visual Studio, so if you want to follow me along, you can download Visual Studio. I will provide a link in the description. But if you don't want to follow me along, you can use whatever compiler you want. I use Visual Studio because it's a very popular compiler. But you can also use any other compiler. You can even skip this video if you already know programming and go to the part 2. I will also provide a link in the description. And if you don't know programming, so here is your chance to understand a bit of C programming because you're going to use it to program. You can copy and paste the code, but it's better if you understand what each line means. It's not very hard. I will be trying to explain it as much as I can. So, without further ado, let's get started. When you download Visual Studio, go through File, New, Project, and select Visual C++ and select Empty Project. Now, if Visual C++ doesn't show up, be sure to open Visual Studio Installer and download it from there. When you've downloaded Visual C++, click on Empty Project, rename the project whatever you want, and click OK. Now we have created an empty project. Now go to Source Files and add a new item, and it's going to be a C++ file. Now we have created a C++ file, and we can start from now. So I'm going to talk briefly about programming. What is programming? Programming is giving instructions to a machine. However, the machine will take the instruction word by word. So if there is an error in syntax or a logic error, the machine won't be able to execute the command. The machine doesn't know what you mean. It knows what you write. So if you write something wrong, the machine won't be able to execute it. That is briefly programming. Now before we start writing instructions, I want to explain some things you need to understand. I will put a timestamp on all the things I'm going to explain through this tutorial right now. If you know something, you can skip along. And if you don't know anything, don't worry, I will explain everything entirely. So let's start with the first thing I want to explain, and that is variables. You can imagine variables as boxes which can contain a certain data type. This box can contain a circle, this one a square, and this one a triangle. Also, to differentiate between boxes, each box has a unique name. This one his name is box 1, box 2, box 3. So when I'm calling box 2, you know which box I'm talking about. This is the same thing with programming and the syntax of variables. So when we want to declare a variable, we have to first start with its data type, and the second thing, its name. And then you can give it a value. We're going to bother now in this tutorial with 3 data types. The first data type is the integer, the second is the float, and the third is the string. The integer can hold whole numbers, like 1, 2, 3, or 4, or even negative numbers, -1, -2, -3, but it can't hold numbers with decimal. Float, on the other hand, can hold numbers with decimal, like 1.2, 0.1, etc., and even negative numbers with decimals. You can use an integer as a float, but you can't use a float as an integer. What I mean by this is you can't have 1.2 as an integer, but you can have 1 as a float. However, if you're sure that your item is an integer, it's better to call it an integer for storage memory. Yes. Also, we're going to bother with the string. The string is data which can hold like phrases, words, letters, whatever you want. So we're going to use also this data type. To declare a variable, so we start with data type, so int, short for integer. You don't write integer, you write int. And the name, so test. And you finish your syntax with a semicolon to tell that your command is finished. Now some programming languages don't use semicolons. C does, so you have to end each command with a semicolon, so the compiler knows that the command after is another command. It's not the same command. Now we have declared a variable called test. However, we have not given it any value yet. We know test can only hold whole numbers, 1, 2, 3, or 4, but we don't know which value test contains right now. Each time, test can only contain what value at a time. However, you can modify the value of test at any point you want. So in order to modify it, we must first write something that I will explain to you in a bit. We write void main, parentheses, and brackets. What void main does, every command you want to execute must be inside these two brackets you see of void main. Why is it so? Because the compiler, when you want to compile your code, or execute it, in other words, it will see where you written void main and will execute only the commands written in void main. It doesn't execute any command written, if you want, under void main or over void main. So if you want to write something there, it doesn't execute it unless it's exporting a library, which we're going to talk about it later. So inside void main, we're going to declare our variable int test, and we're going to give it a value. And to give a value to a variable, you write the name of the variable test, and you give it a value, test equals 3, or you can use whatever arithmetic operation you want, and like, for example, test equals 3 times 3, and if you know your multiplication table, test will be 9. Now I want to show test. In order for us to show test, it isn't required in random app scripting to show the variables. But here in Visual Studio, I want you to see the value of test and how it's being affected. So I will write 2 lines of code, which you don't need to understand. Basically, these lines of code are exporting a library. In order for us, a library is a set of codes that we can use without defining them. And we want to use one command of this library, which is to display us the value of test. So we're going to write include IOStream. We're going to include the IOStream library and using namespace std. So in order for us to use the commands of the library, and we are going to use the command cout. Cout is basically display us the value of test. And we execute this code right here, and we can see the value of test is being 9. Now if you want to modify, for example, test equal 2 times 3, which should give us 6, as you can see, the value of test is being modified. Now you can go and play around, do whatever arithmetic operation you want, and the value of test will be modified each time. Now you can also use arithmetic operations on multiple variables. So we want to declare another int called u, for example, or ut, uy, doesn't really matter. And also you can assign it directly with an equal sign, or you can go and, for example, use uy equal 2. And you can also set, for example, test equals uy, for example, or let's name it something conventional like x. For example, test equals x times 3. You can modify, for example, to give it a unique value, 7. As you can see, the test will take the value of x, the last value of x it has, like here it's 7, and the times 3, so it should give us 21. And here, as you can see, it gave us 21. So it will see the last value of x before this line. I'm telling you last value of x because you can modify x before you start. And it will give us the answer times 3. So you can play around with multiple variables. Even if you, for example, declare test equal 0, and you write test equal test times 3, it will search for the latest value of test, which is 0, and will assign the value of test times 3. So it should give us 0. Yeah, because 0 times 3 equals 0. So here when you want to use another variable, it gives you the value of the last time you assigned the value of test. Now you can't like not use this code because test doesn't have an early value, so you haven't declared any value of test, and it will give you an error. It will tell you that test is undefined, uninitialized local variable test. So yeah. Now that you know how variables work, we can talk about if statements. So what are if statements? You can imagine them as the conditions in Age of Mythology. So if a certain condition is satisfied, you can execute a bunch of code. If it isn't satisfied, you execute another bunch of code. So let's try to make a program to illustrate this. So we'll use variable test, or let's use another type. So let's use float. So float test. Now we'll set the value of test equal 1.5. We'll say if the value of test is greater than 1, you use the brackets, or if it's a single command, you cannot use the brackets. But it's better to use the brackets to see all your ifs if you have multiple ifs in your code. So if test is greater than 1, we'll see out test. If it isn't, we'll see out, it means that we'll display 0. So we know already that test is greater than 1, so the first if should execute, and we'll delete this command. So we'll start our program, and it should print 1.5. Yeah, as it does. But if I go and change the value of test, so it becomes 0.5, now the condition isn't met anymore. The 0.5 is less than 1, so it should print 0. As you can see, the if statement works this way. Now, what are logical operators? Logical operators are the operators you put here. So you can put here greater or less than. You can put greater or equal. Greater doesn't work if the value is like 1. If it's 1, it will display still 0 because it isn't greater than 1. But if you put greater or equal than 1, it will display 1. So yeah. Also you can have, if you want to test if the value is equal to 1, you don't write equal, you write equal equal to differentiate between this operator and this operator. So this is a test to see if a variable equal 1, and this is assigning the value of 1 to the variable test. So you use 2 equals, and if you want to check if test is not equal to 1, you write exclamation mark and equal. So we'll see here, if test is not equal to 1, so for example if it's 2, it will display the value 2, because we said if it's not equal to 1, then we display the value, else will display 0. So if it is 1, it doesn't verify the first statement. Test is not equal to 1, so 2 not makes it to see if like test is not equal to 1, so we enter the else. Yes. Because test is equal to 1, so this condition isn't satisfied, and we enter the else. So this is everything you need to know about if statements. They are like the conditions in Age of Mythology. If they're true, you execute everything inside the if statements. You can have multiple commands if you want. And if they're not true, you execute everything in the else. Now, not every if requires an else. And you can put multiple ifs. It doesn't have to be one if in a single code. And you can use also multiple ifs inside ifs. So for example, if test is not equal to 1, and if you have, for example, another variable like float x, and you can use if test is not equal to 1, and for example the other if must the code here, for example cout x, in order to execute this code, the two ifs must be satisfied. So this if must be satisfied, in order to enter this piece of code. And then if x is less than 2, this piece of code is also satisfied. So let's give a value of x 1. And let's use here the operator equal equal. So here the test is equal to 1 and x is less than 2, so we should be able to see out test and see out x. As you can see, it writes 11, but it's 1 and 1. We haven't put any spacing. I won't bother to tell you how to do spacing, so I will tell you anyway. So if you want to have spacing, you can write like this. See out a space and x, so it should be 1 and 1. Yeah, like this. If you want me to do a series on how to program in C, I have no problem. So I know a bit, so I can tell you. Put that down in the comment if you want me to do this. Yeah. So let's change the value of x to 2. Now the condition is no longer met because it isn't less or equal than 2. So we will only have 1, 1. Yes. That was all I wanted to tell you our ifs. We won't enter very complex ifs. I think in the IAM scripting we'll only have one tier of ifs, so this one won't be even there. But I told you if you have 2 tiers of if, how they work. Now we'll talk about for loops. What are for loops? When you want to repeat a command or a bunch of commands multiple times, you use for loops. You can go ahead and copy paste them however many times you want, but it isn't really tidy, and if you want to copy them 100 times, it isn't really feasible. So this is why we use for loops. What is the syntax for loops? For loops are declared like this: for, and we use a thing called a counter. A counter is an integer, a normal integer as we saw earlier, but the first initial value is 0. However, you can change it, but for the purpose of this video, let's stick to 0. It's very easy to understand if it's 0. And every time you execute a command, the value of the counter will increase by 1. And when it reaches the amount of time we want to execute the command, let's say we want to repeat a command 4 times, then the I will be equal to 4 and will exit the for loops. So let's see how we write them. For int I, we want to declare an integer called I, equals 0. So we set the value of I to be 0. And then we want to finish our for loop when I is less, we want to continue our loop while I is less than 4. So this is the command that will tell us to continue our loop while this condition is true. It's like an if, but will continue while this condition is true. So first I will be equal to 0. And every time we execute the command, like the for is divided into 3 separate commands. The first one is the initialization. The second one is the condition, where we'll exit our for loop. And the third one will be the incrementation of I. So every time we want I to be incremented by 1, to have its value increased by 1. Now you can write this syntax, or you can write I++. It doesn't really matter. I++ or I equal I plus 1, it's the same thing. Programmers use I++, so if you see it, I++ is the same thing. Now we want to repeat a command. Let's say, for example, test equal test plus 1. The first time the value of I is 0. Then it executes this command. So test will be 2. The second time, and when we execute this command, the I will be increased by 1. So the second time I will be 1. And then test will be 3. And so on and so forth until the value of I is equal 4. Then we have this condition is no longer valid. So we'll exit the for loop and we'll execute the rest of the command. So we want to see out, you know what see out means by now, the value of test. Now if everything worked correctly, test should be 5, because we've added 1 4 times, so it's like 1 times 4, and 1 times 4 plus 1 is equal 5. So yes, the value of test is equal 5, and as you can see, everything works. Now what we'll use for loops in Age of Mythology, we'll use them, for example, to repeat a command for the number of times we have players. So here the I will be equal, will be less than the number of players. We want to repeat, for example, we want to give settlement for each player. So we won't go ahead and predict how many players we'll have, or write ifs the number of players like 9 times if you have 9 players. No, we'll use for loops We repeat each, we'll give, for example, each player a settlement for the number of times we have players. Yes, for loops are very important in programming. You don't copy and paste commands, you use for loops. Finally, we'll talk about functions. So what are functions? Functions are like a shortcut of a code. If you have a code and you know what it does and you want to repeat it over and over again, like for example the calculation of a factorial. If you know what a factorial is, it's for example factorial of 5 is 5 times 4 times 3 times 2 times 1, etc. Or for example a code that does the power. Because you can't do factorial in the coding, you have to write a function for it. So if you want to repeat these calculations multiple times, it's better to use functions. So what are functions? There is two types of functions. There is functions with return type and functions without return types. Functions without return types are like void main. They don't return anything. Or there is functions with return type. I'll show you the syntax of functions with return types. So functions with return type are like normal integer, are like normal variables, except they do a calculation. So the syntax for declaring them is very easy. So we write int and the name of the function. For example, we want to calculate the power of 4 of a certain number, but you write parentheses and brackets. It's like this syntax. And here you do the calculation. Now I told you that any code outside void main won't be executed. But when you use functions, you usually call them in the void main. So you call them there, and then the compiler will go to there and execute everything there. So technically you call them in the void main, so they will be executed. And here in the parentheses, you usually give arguments to a function. So here, by the way, if you have this glitch, it's not a glitch, you just press insert on your keyboard and it will disappear. So here we give it argument. What are arguments? Arguments are numbers that we to begin with our calculation. So our numbers here from the void main, we want to give it a number from the void main, and then it will do calculations for us. Like if you don't give it a number, the functions won't know which number you want to do its factorial or its power for. So here we give it an argument. It's called int x. So it will take an integer from the void main and it will do the power of 4. Our integer, we called it x. So how do we do the power of 4? We name any variable s equal to x, and we'll do a for loop. For, and if you wonder how it did this, it's double tap, so it will give you the full for. For int I equals 0, while I is less than 4, we want to repeat s equal s times x. So every time, in the first time, s will be, I think we should make it 1 for us to be power of 4. S will be 1, so s will be s times x, and it will become 1, and then it will become x, sorry, and then it will become x to the power of 2, x to the power of 3, until x to the power of 4, and we exit the function, the for loop, we exit the for loop. And now we want to return the value of x. We want to tell the void main what value of x you have calculated. In order for you to do this, you write return, and you return x. You want to return the value of x, or else the void main will have no idea what value the function has calculated, and it will give you an error. So if you want to do the power of 4 of h is a variable that I declared earlier, it's 2, and we will display it, so cout. Notice that you can cout the whole value of power of 4, and it will work. Or you can, because our function is an integer, you can save it in an integer. So let's say you have declared int k equal power of 4, and we will cout k. Now that everything is working, we can test this, and it should give us 16. It's 2, so there is something wrong. Let me check. Yeah, there is. We should have returned s, because we calculated s and not x. X is given. S is given from this function, so h will be x, and we want to return the value of s that we have calculated. And now if we do this, we are given 16. So it's 2 to the power of 4, and it's 16. So yeah, that's what you want to do. Now if you want, for example, to be power of 5, you increase the I to be 5, etc. You can give it multiple arguments. So for example, if we want to do a normal power, we don't want it to be power of 4, power of 5. We want the user to tell us which power. You can write, for example, 2 arguments, int x and int y, and we won't name it power 4, we name it normal power. Now, and we want the function to be repeated while I is less than y. So for example, we want to do the power of 5 for a function. You can use the integer already declared, or you can directly give it the value of 5. For example, we want to do 2 to the power of 5. So here is the first argument. Arguments are separated by commas, and now h will be x and 5 will be y. So yes, every value you give them from the main, it will be copied in x and it will be copied in y. Notice that if you change anything in x there, for example, if you change the value of x, the value of h won't change because it's a copy. It's not the value of h directly. There is a way to change the value of h if you change the value of x, but we won't do this now because we won't apply it in IOM scripting. So here the answer should be 32 because it's 2 to the power of 5, yeah, and we give 32. So this is how you use functions with return type. You write the return type of the function, so it returns us an int, the arguments there, and the name of the function. I meant name of the function and arguments. And here to call a function, we'll call it by its name and the arguments there. Now you saw how to use functions, and yeah, so you have a good baggage for us to continue our tutorial. Now I'm sure you will understand most of the code for IOM scripting. Now there is more advanced things you can learn, but this isn't our focus for this tutorial. I may do an advanced part on random map scripting and an advanced part on C++ programming. There is classes and many things, but for now you understand the bare minimum for us to be able to tackle the random map scripting subject.